Okay, so let's look first at this example. Here's an example without a slant asymptote. So what I want you to be doing when you're creating graphs, you're going to simplify the function if you can. You're going to determine the horizontal and vertical asymptotes and sketch those guys. You're going to find the slant asymptote if that's appropriate. You're going to find y-intercepts. You're going to find zeros. Those are the x-intercepts. And then find a few more points to kind of fill in the graph. And then you're going to sketch a smooth curve. So all this is now done without your calculator. So now put the covers back on your calculator, because we just used our technology a few minutes ago, and now we're going to do this without our technology. So where I would usually start is the asymptotes. Okay? So based on our discussion of asymptotes, let's talk first about a horizontal asymptote here. What's your horizontal asymptote going to be? Go ahead, Becca. Your horizontal asymptote.
Okay. 0.
The ratio of the coefficients. Okay, awesome. I thought you wanted to be recorded. That's why I called on you. It sure is. Okay, so y equals 3. All right, you were thinking of vertical asymptote.
Yeah.
Okay, do you want to tell us that one? -4, okay. And we're going to call that x equals -4. Every time you guys list a vertical asymptote or a horizontal asymptote or a slant asymptote, it's always in the form of the equation of a line. Don't just give me a number, okay? So now what we can do is sketch those two. So y equals 3 is right up here. You guys all have graph paper out? I want everybody to create this with me, okay? We're all practicing together. So y equals 3 is right along here. And then we have x equals -4. 1, 2, 3, 4. That's right here. Okay? And so now we want to find x and y intercepts. Okay? So let's plug in a 0 for x. When we check f of 0, we end up with 0 over 4. That's 0. So if I plot the point 0, 0 right here, I've essentially found the x and the y-intercepts at the same time, okay? When x is 0, y is 0. When y is 0, x is 0. So there's only one intercept. All right, so that's, gives us a little bit of a idea of the graph. I know I've got a point here and I've got some asymptotes. So what you want to do at this point now is just check some more points, okay? Maybe check some points kind of to the left of that origin point, check some points to the right of that origin point, and then we'll start to create a smooth curve, and that curve will sort of follow the asymptotes a little. So since this is 0, maybe I would look at, I don't know, maybe f of 2, for instance. So if I look at f of 2 and plug that into my original function, I get, looks like 6 over 6, so that's 1. So f of 2 is 1, that's going to be right up here. And then maybe I'll go a couple units to the left, maybe I'll look at f of -2. And you can just choose, what you think are going to be convenient points. Also looking at your function, see if there are any points that would work nicely with your function. So if I choose -2, now I have -6 divided by 2, so that's -3. So the point -2, -3 is on my graph. Oops, looks like my calibration's a little off. Okay, so I'm going to take 1 second to fix that because I'm going to have a hard time drawing otherwise. Yeah, it's been a little off.
I'm supposed to rush through it. I was taking it sweet.
Ethan, you did this for me?
Yeah.
Did you create a little booby trap for me?
Demon.
Okay, we'll see if that's any better. I don't know, maybe not. All right, so let's connect the points. And we know that as we connect these points, it's heading up towards this asymptote to the right, and it's heading down towards this vertical asymptote to the left. And there we have it. All right, so that's part of the graph. Now this is a function, so we know that we've graphed pretty much everything we're going to find to the right of -4, because if we put anything up in this other quadrant, it wouldn't be a function anymore. So let's look to the left of -4. So let's look at some points like maybe f of -6, and maybe f of -8, and maybe f of -10. Just look at some points. So if I look at f of -6, I plug that in here, and I get, looks like -18 divided by -2, so that's 9. And then f of -8 gives me -24 over -4, that's about 6. And then f of -10, that gives me -30 over -6, so that's about 5. So let's start plotting those.
Wait, this year?
Yes.
Will the recalibration be on my phone?
It will. Everything is. Everything we did. It's okay. All right. So we have -6, 7, 8, 9, 10. So there's -10, and the point is 5. So 1, 2, 3, 4. Look at the plot there. And then we have -8, and that point is 6. 3, 4, 5, 6. And then we have -6 and 9. So 3, 6. That's going to be about up here. So again, just kind of connect those points with a smooth curve. Something like that. Okay? So that's, pretty straightforward. We don't have any slant asymptotes. We don't happen to have holes in the graph or anything like that. But if we did, I'm sure you could fill that in. I wrote this stuff in function notation, I wrote f of 0. If you want, you could also make it as a table. It's really a matter of preference. Like if you want to write x and f of x or xy, and then you can just put the coordinates, you can say the point 0, 0, the point 2, 1, the point -2, -3, etc. So however you want to set up the values is fine. Okay, anyone have questions on that? So that's everything you should have been able to do up to today. And now the next example has a slant asymptote. So let's take a look at the next example. And I'll just get rid of all this first. All right, so let's take a look at this example. This one does have a slant asymptote. And maybe I'll enlarge this just a hint. Yeah, there we go. Okay, so we know it has a slant asymptote. Why? Teddy?
Because the numerator is...
Because what?
The numerator, x squared, is 1 multiplied by x on the denominator.
Awesome.
So it's actually 1.
Exactly one more.
Can you hear me?
I hear you. Yeah, the computer's picking you up. The microphone's pretty good. All right, so the degree of the numerator is exactly 1 more than the denominator. So we need to do our long division to figure out what that slant asymptote is. So we start with x squared. We're going to divide by x minus 2. So I do the division. I just get x. X squared divided by x is x. So now multiply. X times x is x squared. X times -2 is -2x. And now subtract. So this part gives us 0. Subtracting the negative. Please remember to do this distribution there so we don't mess that up. So subtract the negative. That gives me 2x. And now when I divide again, 2x divided by x, that just gives me +2. When I multiply again, I have 2x minus 4. Again, when I subtract, I get 4. But at this point, I can really stop because I have a linear term, that's the x, and I have a constant term, that's the 2. So that is the slant asymptote. That's the equation. So y equals x plus 2 is my slant asymptote. Whenever I have a slant asymptote, I'm not going to also have a horizontal asymptote because the degree of the numerator is exactly 1 more than the denominator, and that's why you get the slant asymptote. But I will have, let me just write this in here, slant asymptote. I can still have a vertical asymptote, and what's the equation of the vertical asymptote? Do you know, Angela?
No.
The vertical asymptote, so we're looking at where the denominator is 0.
Would it be x equals 2?
Yeah, that's right. So we have x equals 2, so that's our vertical. Okay, so now we can start to graph those. So I'm going to graph x equals 2. That's right over here, and I want you guys to do that as well on your graphs. Graph x equals 2. And then graph x plus 2. So there we have a y-intercept at 2, and then slope of 1. So this graph goes off this direction, and then comes down through here. So there's our slant asymptote. And yours will be better than mine because you have a straight edge or a little easier to draw. Okay, so we have a slant asymptote, a vertical asymptote. Now let's let x equal 0. So if we look at f of 0, that'll give us a y-intercept. When x is 0, we get 0 over negative 2, so that's going to be 0. So it looks like, again, we happen to get an x and y-intercept that are the same. That won't always happen. That just happened to be the case in these two examples. All right, so now we have, kind of a big area there. Let's just start choosing some points. Maybe since I have a point here, I'll kind of look to the left and right of 0. So maybe I'll look at f of negative 1, and I'll look at f of positive 1. When I plug in negative 1 to my original function, I just get 1 over, that's going to be negative 3. And then when I plug in positive 1, I get 1 over negative 1. So negative 1, negative 1/3 is about right here. Positive 1, negative 1 is about right here. So right now I have these 3 little points. Maybe I'll look, I don't know, maybe I will go to 1, 2, 3, maybe I'll go way out here, like negative 4, just to kind of get a better sense of it. When x is negative 4, now I have, it looks like 16 over negative 6, and that's the same thing as negative 8/3. That's the same as negative 2 2/3. So 1, 2, 3, 4, negative 2 2/3 is about right here. And now it's really starting to take shape, that graph. So connect these dots with a nice smooth curve and create a curve that is heading towards the asymptotes. Okay. Any question about that? All right, now it looks as though we've covered everything to the left of our x equals positive 2 asymptote. If we look to the left of that, this function is going to continue down and to the left. So there's not going to be any other points in this area, okay? Otherwise it wouldn't be a function. So let's look to the right of x equals 2 and test a few points. So maybe like f of 4 and f of 6 and maybe f of 8, something like that. So f of 4 is going to give me 16 halves, or 8. And then f of 6, that's 36 fourths, or 9. And then f of 8 is going to be 64 sixths, and that's something a little bigger than 10. That's kind of taking me off my graph, but let's see what we got. So I have, maybe I'll look at f of 3, because that's just to the right of 2. F of 3 is going to give us 9. Okay, and we see f of 6 is also 9, so there must be kind of a turnaround point in between there. And that kind of makes sense, because that's what f of 4 looks like. So f of 3 is 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be up here somewhere. And then f of 4 is 8, so that's down 1 unit. And then f of 6 is also 9. And then f of 8 is somewhere up around 10. Let's see, where am I? 2, 4, 6, 8. f of 8 is up here somewhere. In fact, I think I put my 6 in the wrong place. Yeah, I didn't go over 2 units. So I want 2, 4, 6. I should do that right here. Okay, so then connecting with a nice smooth curve, and you guys are going to have a better time in this with your bigger graph paper than I do. It's going to kind of look like that. And you can see how the slant asymptote is going to be sort of the boundary. Teddy.
In cases of having a slant asymptote, are you always not going to have a horizontal asymptote?
That's right.
Or could you have a horizontal asymptote with the slant asymptote and no vertical asymptote?
No, because whenever so you're looking at the degree of the numerator and denominator. So if the degree of the numerator is greater than the degree of the denominator, it's either going to be more than, it's either going to be 1 bigger, in which case you have a slant asymptote, or it's going to be more than that, larger. And in that case, you have a horizontal. So it's an either-or situation. All right, so any other questions on creating these graphs? This is what I want you guys to be able to do, is create a really nice graph. Use your rulers, make it nice and neat. Label what's your slant asymptote, label your vertical asymptote. Find some points. If you find a minimum of 3 points per branch of the graph, that's usually sufficient. You can usually work with the asymptotes and get a sense of where the graph is going. So that all would be fine. Any questions at all? Okay, for tonight, for homework, let me turn this off real quickly.